Okay, so we're on part number 157. This is line 18A, 3z2b6 T2K, Super-Kamiokande Neutrinos Sparticles CERN LHC NCpi0s 5G UFO Wow Seti. Again, the data in this one is from 2012. This is the alien radio signal found in the Wow Seti. What I did was Google bring anti-neutrinos to equilibrium, and this PDF file came up. Or sorry, I think it's a book. It's called Relativity, Gravitation, and Cosmology, a Basic Introduction by Tai Sheng. It says the condition for a new equilibrium stage to take place is given by the condition for neutron, proton, electron, positron, neutron, and antineutron respectively. Again, when you get a PDF file or a book that comes up in the Google data, it means it has something in it that can be used towards these formulas or towards these calculations to get to the 5G force for the UFO engine that we want to build, okay? So here's, or that you want to build. I can't build it. You guys are going to build it. I'm just giving you the data how to do it. So here's the pretty picture. And these are neutrinos. Aren't they pretty? With muons and stuff. So anyways, this is what it says. The first T2K event seen in the Super-Kamiokande is seen in the image above. Each dot is photomultiplier tube, which has detected photons. The two circle of hits indicates, there's two circles there, see the two circles? Indicates that a neutrino has probably produced a particle called a pio. Now, when I saw that, I thought that was really cool, because pi and 0 both come up in the Wow Seti signal. So this is totally, in relation to each other. Perfectly in time with the arrival of a pulse of neutrinos from J-PARC. So you've got a pulse of neutrinos, plus you've got your, this pi particle. And then you got your photons. So they're all three of them are all together there. So there's another faint circle surrounds the viewpoint of this image, showing a third particle was created by the neutrino. See? They still don't know. They didn't name this other particle yet. They said there was another particle produced. But what if it's actually the neutrino that is split? And remember I said it splits into 4 quarks, or 4 different particles? So I bet you that's part of the actual original neutrino that after it collided, it split somehow. You guys learned how to split it. You know how to split them now. You know how to split the neutrinos now. So whatever you did to get this test is what you need to do to split your neutrinos into 20 parts. And I'll show you. In the videos from line 17 to 18, there are formulas there to show you how to do it. I don't know if they'll work, but you can try them. Okay? So here's a quote. The T2K experiment has been built to make measurements of unprecedented precision of known neutrino oscillations and to look for a so far unobserved type of oscillation which would cause a small fraction of the muon neutrinos produced at J-PARC to become electron neutrinos by the time they reach Super-Kamiokande. So you're trying to take a muon and make it electronic so that it has an electronic pulse, it has electricity in it, and electricity can communicate with other particles. So what you need to do is mix it with a particle that has electricity in it, or that creates electricity. I'm going to put that down. I'll see if I can find something that creates electricity, because that's a good idea. A particle that creates electricity. How about static? Static does. What kind of particles are created from static? And we'll use those. Okay, observing the new type of oscillation would open the prospect of comparing the oscillations of neutrinos and antineutrinos, which many theorists believe may be related to one of the great mysteries in fundamental physics. Oh, I love mysteries, and I love solving them. Why is there more matter than antimatter in the universe? Well, maybe we'll find out by the time we're done all these Wow Seti lines. You never know, right? The observation of this first neutrino means that the hunt has just begun, said Koichiro Nishiwaka, director, sorry if I've said your name wrong, okay, director of the Institute for Particle and Nuclear Studies at KEK and founder of T2K, The first physics results are expected later this year. Today's news, he says, is the beginning. I found this on the blogs.psychicstoday.org. And I found another one. T2K neutrino observed at Super-Kamiokande on February 25th, 2010. Since LHC starts a run at 7 TeV collisions, March 30th, 2010. Physics Today, CERN's Large Hadron Collider has finally started colliding two 3.5 TeV circulating beams of protons together to produce 7 TeV collisions. So you've doubled your collisions just by using that particular beam of protons. Okay, so we need a beam of protons. Now, if you look at the formulas in line 17 and 18, we do talk about a different type of laser beam. There is a new invention out there that you haven't used yet that can actually increase the proton beam TeV. So now I understand what that means. I didn't know what TeV meant before, so you want to increase your TeV. Okay, so I'll look for that for you. And the official start of the LHC research program. So here's a pretty picture for us to look at. This is from CERN. It's a CMS experiment at LHC and CERN. So the collisions above, image credit to CERN, occurred at 13:06 Central European Summertime, according to a live broadcast from CERN. Okay, I'm running out of battery power, which means I'll probably have to put some of this video into the next one, okay? Just so you know. Quote, "It's a great day to be a particle physicist," said CERN Director General Rolf here. "A lot of people have waited a long time for this moment, but their patience and dedication is starting to pay dividends." And my thoughts. That my theory of the neutrinos splitting into 4 quarks isn't all that far off based on this T2K event in Super-Kamiokande, where it splits into 3 particles. A neutrino particle is called pi-O. Do you see what I see? Pi and the symbol for 0. Both have been found in the Wow Seti signal lines of data. Freaky or what? So I googled T2K neutrino. This might appear on the next video if I run out of power because my thing's flashing, okay? So T2K is Tokai to Kamiokande, Japan. That's where they send the signal. It's a particle physics experiment.